guys. So this last video in this three-part series is going to be focusing on a factorial ANOVA. And so with a factorial ANOVA, you're basically comparing two independent variables to each other and you're crossing the data. Kind of like a t-test, but if there were more than two factors. Yeah, so let's just get into it. So we're going to go to Analyze, and then we're going to go to General Linear Model. We're going to go to Univariate. In our dependent variable, we're going to do total attitudes, and then our fixed factors is going to be Q6 and Q10. For the model, you don't have to worry about this. For the contrast, you don't have to worry about that. And then the plots, you don't really have to worry about that, but I like making two just in case that your bar doesn't really make sense, like your graph doesn't really make sense. You can do both graphs in this scenario, so we can do that. We're going to click continue. For post hoc, you need more than two factors because you're trying to differentiate which out of over two factors is significant and which ones are not, if there are ones that aren't significant. So we're just going to move on weekends since there's more than one of those. Gender, there's only two in this research scenario. We're going to do the Tukey, and then we're going to click continue. And then once we're here, we're going to go to options. I always do descriptives. And then we're going to click OK. Yeah. And then we're going to look at this table right here, this test of between subjects effects. So this error bar right here where this DF is going to be your degrees of freedom. These two, or this is going to be your degrees of freedom 2. Your degrees of freedom 1 is going to be these, which is 2. And then gender just has 1 because it has 2 factors. Yeah, and then how do we report this? And here are the graphs. So as you can see, one of the graphs doesn't really make sense, and then this other one does. So you can see Netflix and chill and napping all day correlates with each other, but outdoor adventures don't correlate with these two or crossover. Yeah, so how do we report this? It's not that hard. The biggest difference between this and the other ANOVAs is that you have 3 variables, or 3 hypotheses rather than just 1. And so there will be significant difference in attitudes towards looking for partners. In 2 gender conditions, there will be significant difference in attitudes towards looking for partners between the 3 weekend activity, and there will be significant interaction between gender assigned at birth and weekend activity in terms of attitudes towards looking for partners. We're going to look at this data. The significance is what we need. Since it's less than 0.05, we see that all of this data is significant. So in our report, we're going to write something like this. The significant differences of the conditions were examined using a 2x3 independent ANOVA. So that just means 2 factors compared to 3 factors. The results found significant differences for the gender condition. Here's F, and then 1 is for the gender condition. That's the degrees of freedom 1. And then 389 is the error, and then the F value is 16.77. And then it is significant, we can see here. And then males, here's the average, have more positive attitudes towards looking for partners via dating apps. And then for weekend activities, same thing, only the degrees of freedom 1, since it's for weekends, it's number 2. To know the math, the degrees of freedom for these tests is just the n-1. So if there's 3 factors, your degrees of freedom 1 for something with 3 factors would be 2, and something for 2 factors would be 1, and so forth. Across 3 situations, there's no significant differences between condition 1 and condition 2, as p is greater than 0.05. However, there's a significant difference between those who prefer outdoor activities and napping all day. As figure 1 shows, there's a significant interaction, F of 2, 389, and then F equals 730, and it's significant. This means that gender and weekend activities affect how people feel about dating apps. Hence, all alternate hypotheses are accepted. And then, yeah, that's it, guys. Have a great day.